Claudio Maccone, who is the head of the Italian SETI project, which is the search for extraterrestrial intelligence, invited people from the International Big History Association to meet with them in order to think about life in the universe, big history, SETI, and the future of humankind. And my comments here at the conference are on SETI and big history. What is the relationship between the two of them? What difference does this make to the future of humanity? And I'm going to start with a few comments on different views, the changing views of the past that we've had. This is just a few of those possibilities. I want to start by looking at religious or traditional history, the national or politically defined histories, the development of world history, the development of big history, and then how the SETI work is both challenging and extending our views of the past, and I think maybe influencing such things as the future of humanity. But let's start with religious history and how all of these different views of history continue to influence us, even though we have different views on them. The traditional way to begin with is with understanding our current date. The date of my presentation is July 15th, 2019, which of course starts out as being 2019 years after the birth of Christ. So in the Christian view of history, what's important is not the creation of the universe, although people did care about that. Bishop Ussher is famous for having come up with his determination that creation began at 6 p.m. on the 22nd of October, 4004 BC. He wasn't the first to consider that. St. Augustine also thought that history was about 6,000 years since the creation of the world. So that was a fairly traditional date, determined by a very careful reading of not only the biblical text, but other ancient texts in trying to determine exactly how long all the people that are mentioned in that lived and how we can get back to the creation of the world. So that was of interest to them. But what was even of greater interest to them was the new creation, the recreation that comes with Jesus Christ. And so that the calendar, the counting of time begins or revolves around the date when Jesus is on earth. And so even though now we've moved from the year of our Lord to the common era in most cases, the date has remained the same. In either case, we are now in the year 2019. So that tradition continues to stay with us. Of course, in the Jewish calendar, they haven't used the year of our Lord. They use the year of the world, and you've had the rabbis and the Jewish intellectuals who have worked on the sense of time and on the Jewish calendar, coming up with a rather similar date. The date of creation within this view is the equivalent of 3761 before the Common Era, or in the old view before Christ. And given that date, we are now in the year not 2019 but 5779. So the Jewish calendar starts the time with the creation of the world as it was understood at that time. Again, using the method of reading the biblical texts very carefully to determine when the world was created. So this is a traditional religious view that coming out of the Judeo-Christian traditions that we're talking about 6,000 years if we're going to cover everything that's existed. The reasoning for covering that amount of time changed by the 18th century, when at best you had deists, or maybe moving in some secular direction. In any case, you had in the 18th century Joseph Priestley publishing his new chart of history, and he dedicated it to his friend Benjamin Franklin, who considered himself to be very influenced by the contemporary science of that period. So these ideas were not being influenced directly by religious views, but they were still using the traditional time frame that religious history had given us. And so in the new chart of history that Priestley comes up with, the furthest to the left, the furthest back in time that he goes is with the ancient Egyptians and Israelites, which covers more or less the same time periods that traditional religious views had held regarding biblical history. So you have a religious and a kind of a traditional view of periods of time. And the continuing influence of this is that these are still the periods of time covered in most departments of history in universities. History courses will go back over the last decades, perhaps over the last centuries, perhaps as far back as the ancient period. But rarely do you get history courses pushing the time frame that's covered in the courses much before that. The new advanced placement curriculum and tests in the United States argue about whether or not history should begin in 1200 or 1400, but in one way or the other, it's covering the last centuries, the last millennia, perhaps the last few millennia. And so the continuing influence of this traditional view of history is very important. There have been in the last few centuries a push to an even more restricted time period, that national and politically defined histories rather than religiously and traditionally defined histories have been very common, in the sense that lots of courses are on in the United States on American history, or maybe you'll have courses on British history, French history, Russian history, Chinese history, or perhaps regional histories, Latin American history, African history, European history, Asian history, and so on. These have been common designations, and one example of this comes with the famous calendar coming out of the French Revolution itself, being drawn on the French Enlightenment, the goal of which was to replace those old, now outmoded religious and traditional views of history, that the dividing line didn't come with the birth of Christ or something called the Common Era. The dividing line was this cosmic event of the French Revolution. And so under that calendar, the year zero came in what would have been in the Christian calendar starting in 1792. But year zero doesn't begin with the birth of Christ. The year zero begins with the French Republic, that this is when time should begin. That idea didn't last really very long, or at least it wasn't implemented very long. But certainly the idea that what we're really concerned with is relatively recent national histories has been common enough. For example, most courses on international relations, or many textbooks on international relations, begin the national period with the Peace of Westphalia in 1648 after the 30 Years' War, which was a war essentially between Catholics and Protestants battling it out. But coming out of that war was giving up the idea that we could enforce our religious views on each other and get the Catholics or the Protestants to agree with us, and we moved in the direction of national sovereignty more than God's sovereignty, and so that it was the nation state, the monarchs, the political leaders were called sovereigns. It wasn't the Pope anymore, and so you had the beginning of, at least in Europe, the idea of national sovereignty, that this is the beginning point of the modern period, that it's nations, and it's politically defined nations rather than religiously defined cultures that's of greatest importance to us. Maybe an example of this could be the American Historical Association. The AHA was formed itself in 1884, which was the same year that the Washington Monument was completed. It was incorporated by Congress a few years later for the promotion of historical studies. And the AHA's website notes that it is the largest organization of professional historians in the world, representing more than 12,000 members, and serves historians representing every historical period and geographical area. So even though it does cover every historical period and geographical area and has thousands of members throughout the world, the name of it is the American Historical Association, and that this it makes perfect sense to those in the AHA. Somewhat similarly, we have the American Political Science Association that was founded a few years after the AHA, founded in 1903. It too claims, this time a little bit over 11,000 members in more than 100 countries. So its members come from around the world, but they are all members of the American Political Science Association. Both of these organizations were founded at the beginning of what Walter Lippmann would later refer to as the American century, the idea that America was the world's greatest power, as the people in the United States often repeated, that some argued for an American exceptionalism. There was something specifically noteworthy in the American experience, and so it makes perfect sense to name the study of history and politics by America. So the American Historical Association, the American Political Science Association, comes out of American leadership, and so this all makes perfect sense within the tradition of America being a shining city on the hill and guiding world history and perhaps all of human history. At that level of self-confidence, perhaps hubris and arrogance, broke down at the time of the Vietnam War. And here a half a century ago, in the 1970s, there were quite a few people and academia who wanted to move away from that emphasis on America, and so you have the beginnings of world history, not religious history, not that traditional history so much, but not national or nationally politically defined history and study of the past. So they wanted to move in the direction of a cross-cultural, comparative, and global approaches. The purpose of the World History Association is to promote understanding among and between peoples and to create a global consciousness. One of the first great textbooks in the world history field was by Bill McNeill, who pushed the time frames back about as far as made sense to many within the discipline. He starts out. He says the first great landmark of human history was the development of food production, moving into the agricultural period. This permitted an enormous multiplication of human numbers and laid the basis for the emergence of civilizations. So how, when, and where hunting and gathering give way to farming and pastoralism is uncertain, but one of the earliest and most important instances of this transition took place in the Middle East between 8500 and 7000 BC, before Christ, that is, or now we would say BCE, before the Common Era. In one regard, this was a bit traditional, though, wasn't it? It starts in the Middle East. It doesn't start in the Garden of Eden, but it starts in the Middle East, and it's now not just 6,000 years ago, but it's within about 10,000 years that we start the story. This is still within a fairly traditional time frame, and it's looking at human history over the last 10,000 years. And so it's world history, but it is still being influenced by rather traditional time frames. The change that was made in this really comes not so much from professional historians, but from the natural sciences and from the images that came in from space. Eric Chasen, an astronomer from Harvard, interested, of course, in the cosmos, talks about this in his book Cosmic Evolution, a later book Epic of Evolution. Fred Speer, coming out of biochemistry, was deeply influenced by the Earthrise picture from the moon, and these images from space gave a new sense of the Earth. And certainly the sciences, the natural sciences, gave a new context for how we were going to think about the past, answering such questions as how did we get here and what can we expect in the future? What is the future of humanity? And these are some of the questions that the both of them were asking, and that the natural sciences took it for granted increasingly because of the work done in geology, biology, astronomy, physics, and chemistry, and others, that the time frames that we need to be talking about in geology are millions and billions of years, in biology, millions to tens and hundreds of millions of years, astronomy, billions of years, and so on, and that these time frames rolled off the tongues of people in the natural sciences, not so much for those in the liberal arts and the social sciences who can. David Christian was the one who coined the term big history. Now, he did come out of traditional national or politically defined history. He was he is an Oxford-trained Russian historian, beginning his career writing about the last century or two of Russian history. He then wanted to put that within a much larger context of drawing on the work done in the natural sciences, and so he's the one who coined the term big history, saying that if we're going to talk about history, we can't start with the Russian Revolution or with the czars or with nations or even with agriculture. We have to put human history within the context of the entire past if we're going to understand our own origins. So in his recent book, Origin Story, he's interested in the big history of everything, from the Big Bang to the first stars, our solar system, life on Earth, dinosaurs, Homo sapiens, agriculture, an ice age, empires, fossil fuels, moon landing, and mass globalization, and what happens next. He's asking the question of our origins and where we're headed. What does this mean for our future? what are the big trends that we see coming out of the past, and what can we use those? How can we use those to think about our future? And so big history begins with the Big Bang and goes in stages from that point, 13.82 billion years ago, until our contemporary period, with an eye on where this is taking us. Some of the themes that come out of the study of big history is one of them being the idea of emergent complexity, that you have starting out relatively simple in the course of the universe's history, but then moving on to greater and greater complexity over time. So you have relationships within relationships within relationships as you start off. You start out with up and down quarks forming relationships through the use of the strong force within protons and neutrons, and then they become incorporated with electrons within atoms. Then you have the fusion of these atoms into heavier elements in stars, and through the collisions of neutron stars, and then we have the chemicals of combinations of different elements. You've got terrestrial planets such as Earth with its very complex organization. You make this great transition to life on Earth with prokaryote cells, the simplest of cells, the more complex cells, that with the nucleus, and more organelles and eukaryote cells, different cells working together and forming increasingly complex life forms in multicellular life. You have increasingly complex intra and interspecies relationships. Especially in the primates, you have various types of kinship groups, and then among humans, you move to multi-kinship groups within villages and cities. You have relationships between cities and nations and empires, and now we're in this process of somewhere in between all of this, forming relationships between nations and empires within a multinational, perhaps transnational set of human politics. But all of these ideas were based on this idea of the emergent complexity of relationships between different entities as they were studied in the past. So these are the topics that motivated the origins of the International Big History Association. Here's a picture of Walter Alvarez, just outside of Gubbio, Italy, who discovered there the iridium layer that was the marker of the KT boundary, or essentially referring to the meteor that hit off the coast of Mexico about 65 million years ago. That is blamed for the extinction of the non-aviary dinosaurs and opening up space for mammalian development, which of course eventually leads to the evolution of humans. But so big history, as it was organized within the International Big History Association, defined itself by seeking to understand the integrated history of the cosmos, Earth, life, and humanity using the best available empirical evidence and scholarly methods. History had long been interested in humanity. Big History said the written record of the human past could be best understood within the natural record of the entire past, and that you needed to start with the Big Bang and then explain how is it that we get to Earth about 4.6 billion years ago or so. How do we have the origins of life on Earth starting somewhere around 3.8 billion years ago, and then what has to take place there before we get to humans? which we have only been around for somewhere between 200 and 300,000 years. So these are much longer time frames than what traditional or national or political histories had used. But it was redefining what we need to study in the past in order to understand our own origins and, in fact, where we were headed, and perhaps understand a new politics that was developing. The images from space continue to influence, though, how we viewed these issues. One of them was the famous pale blue dot image that was taken at Carl Sagan's suggestion by Voyager 1 back in 1990. This was a picture. Voyager 1 had been traveling for quite a few years, and by this point was just almost 6.5 billion kilometers, 4 billion miles away from Earth. And they turned the cameras around so they could take a picture of Earth. And the most you got was this little blue dot. And that gave us a new perspective, much the same way that the Earthrise photo had given us a new perspective back in 1968. Earth looked like a beautiful blue and green planet, but in a very foreboding black space context. And that if we wanted to survive, we really needed to work together on this. I mean, anyway, this was one effect of the Earthrise picture back in 1968. The blue dot picture in 1990 gave us a different perspective. We are really small. We are in the context of just our own solar system, almost indistinguishable once we get out even only as far as 6.5 billion kilometers, which was not at the edge of our own solar system. Another view from a couple of decades later, with Cassini's image of Earth taken from just below Saturn's rings, kind of gave us a similar perspective on this. So not even at the edge of our own solar system, when we took a look at ourselves, we saw just how small we were in relationship to everything else. And of course, the Voyager has been moving on ever since then. Now, perhaps Voyager 1 entering space in the sense of leaving the solar system. And it's been going for a long time, of course. It's been traveling for about 41 years at the rate of around now 38,000 miles per hour. So it's moving at a great clip. And it's taken this long just to get out, just to the outer edges of our solar system. If it wants to travel to the next nearest solar system within our own galaxy, within the Milky Way, at these tremendous rates of speed, 38,000 miles an hour, it's going to take 40,000 years to get there. And that's just to the nearest solar system, the next nearest solar system within the Milky Way, which is 100,000 light years across. And of course, Voyager 1 is not traveling anywhere near the speed of light. If we did want to move around to visit other solar systems, much less other galaxies, we were going to have to do the types of things that were common on Star Trek and Star Wars, traveling at warp speed or traveling through wormholes or so on. But that's not within the cards. Any foreseeable foreseeable future is in reality, although it's great for science fiction. We're stuck with plodding along at 38,000 miles an hour, and that's simply not even close to fast enough in order to have intersolar system travel, much less intergalactic travel. These are simply way beyond our capabilities now. But we know, of course, that there are thousands of planets in solar systems within just our own relatively local area of the Milky Way, over a few thousand light years of us. We've identified over 4,000 of these exoplanets, or planets which are in a habitable zone, planets which are able to sustain liquid water. So far, we can't quite imagine how life would develop if you didn't have liquid water. Perhaps we'll find some evidence of that even within our own solar system, although we haven't done so yet. But on all of these planets where there does seem to be the possibility of there being liquid water, isn't there a good chance that there's life on some of these? But if we're going to get to them, much less if we're going to communicate with them, assuming that some of this life has evolved to become intelligent, that it too has developed technological capabilities and is able to emit radiation, is something similar to TV signals and radio signals and all kinds of other types of radiation, that they would be able to emit those, to send those signals, and to receive our own signals. That seems to be a better way of getting in touch with them than through space travel, where there's been a lot of UFO sightings. Those aren't taken terribly seriously by scientists. That doesn't seem to be credible evidence yet. And it would be really the civilizations that could produce the type of technology that would permit space travel would have to be at least way beyond where we are. And if we're going to do that, we're going to have to get way beyond where we are now. So that doesn't seem to be as likely a way to be in communication with other civilizations, assuming that they exist. And we do assume that they would exist. The Drake equation is basically a way of trying to think about, given the total number of habitable planets, what are the various conditions which would be necessary for life to arise on them, similarly to the way that life originated and developed on Earth. What's the likelihood of that life having enough time to evolve to the point where it becomes intelligent enough to send some sorts of radiation which, given that it does travel at the speed of light, can get between planets at a somewhat reasonable time frame. Isn't there a pretty good chance that this, our own galaxy, and certainly the universe, is filled with that? Here, during the time of Woodrow Wilson's administration, when Woodrow Wilson was president, for example, at this time period, the common wisdom was that the Milky Way was the only galaxy in the universe. The universe and our own galaxy were pretty much the same terms, that there were these rather vague nebula, clouds that would somehow revolve around or move around outside of our galaxy, but they didn't seem to be terribly interesting. It's only within the last century that we've established that there's not just one galaxy in our universe. In fact, there's at least 100 billion galaxies in the universe, and maybe many more. Maybe there's 1 trillion galaxies. But in any case, the universe is much, much bigger, much more complex than what we had thought even just a century ago. And so while we're not the only galaxy, what would make us think that we are the only planet with life? It just seems to make sense that even our own galaxy, and certainly the universe, is filled with with life, and this is sort of what the Drake equation is suggesting. And so the idea of SETI has been that sending and receiving signals is the best way of getting, to learn if there really are other life forms out there, and if they're intelligent life forms are, if they're able to read and emit radiation that we can catch now through the uses of various types of means here. This is where SETI begins to challenge big history, though. Big History studies the cosmos, Earth, life, and humanity. They have a somewhat similar starting point. SETI's interested in cosmic history, but it's not just Earth. It's all of the exoplanets. It's all the planets that could sustain life. It's not just how did life originate on Earth, but the idea of astrobiology. How could life originate and develop on these other planets? And it's not just a study of humanity. It's a study or a consideration of what would it take for intelligent life to evolve on these other planets? And so it opens up, it challenges what's originated. It's still interested in origins, but it's not just the origins of Earth, the origins of other planets, not just the origins of life on Earth, but the origins of life elsewhere, and the origins of intelligent life elsewhere are all the types of issues that SETI is concerned about. And while it's very self-consciously searching for these things, of course, so far it hasn't found any of them. There is no evidence. The UFOs are not credible evidence, and there's been no direct radiation which we have received from other intelligent life forms. Enrico Fermi, the famous astrophysicist, asked the famous question: where is everybody? If the galaxy and the universe is teeming with life, why, after determined efforts, have we not found any of it? And somebody said that there's a bit of a giggle factor in SETI, that it seems rather eccentric to some people. I would argue, though, that even this doesn't worry me. There's two things, and there's two reasons for why this doesn't worry me. First of all, it just makes perfect sense to me that the universe is filled with life. The Drake equation doesn't prove anything, but when you start thinking through it, it just makes sense that there just has to be an enormous number of planets that have seen the origin of life and the development, the evolution of life over time, and the development of intelligent life. Civilizations which may well be beyond us technologically, but we haven't found the evidence for it yet. One reason that's not a concern is because I think just the search, just imagining this, is by itself important, even if we don't find any evidence for this. I think that this points to SETI encouraging us not just to think about an origin story, but to think of a coming of age story. Coming of age, what are the various points of transition that we need in growing up and becoming more mature people over time? And it's finally when we are aware that everything is not just about us. The universe really isn't just all about me. you can understand that when you're very young. But one of the great points of growing up, of coming of age, is realizing that others have independent existences, and SETI assumes this. Whereas Big History, maybe I think a critique of Big History could be that it keeps asking about, where do we come from? Where does our planet come from? Where does our species come from? Where do I come from? That's really what's interesting to me, and how do I understand that? But SETI is saying that's not quite enough. We need to think about where other planets, other life forms come from. In fact, we need to grow up, don't we? We need to come of age in this sense, and that part of this first realization that others exist and that we need to search them out. It's good for us to search them out. It's good for us not just to recognize that others have origins, their own origins in development as well, which makes them different. They have evolved and developed differently than we have. But it's also good for us to form relationships with them. A mature relationship after coming of age is possible only by realizing the others in whom you have a relationship have their own independent existence as well, and that both relationship and a recognition of others' autonomy is crucial. And SETI is looking at this question at a very large scale. It's saying let's look very explicitly. Let's first of all accept that there are other planets that exist, as we now have evidence for, and let's search them out. Let's see if we can't have a type of relationship with them, if we could receive communication, if we could send communication to them, we can self-consciously form new relationships with these other intelligent life forms. That's a certain coming-of-age story instead of just an origin story, accepting that others have origins and that these others are possible types of units with whom we can have a relationship. It also reinforces another aspect of coming of age, and that is that there are, maybe if we don't find anyone else, or even if we do, that these histories go on without us. There are no doubt life forms and intelligent life forms in all kinds of places, and they don't depend on us. They will continue whatever happens to us. That history goes on without us. It doesn't all depend on me. That there is a reality, even with radiation. As fast as radiation goes, it doesn't have infinite speeds, and it can take years, or sometimes hundreds or thousands of years, for radiation to cross these vast spaces. So we might receive signals from civilizations 1,000 years after they have blown themselves to pieces, and that they might suffer from some of the same problems we do, and they end up going extinct. And so by the time we have learned about them, they are long gone. Or it might be the same with us. We may send out radiation, various signals, and others will read them and find out about us 5,000 years from now, or 100,000 years from now, after which perhaps we are no longer there. So it reinforces this sense of mortality, which certainly comes along with coming of age. It's not just where do we come from, but what happens, how do we imagine the future in our absence? This is true individually. It's good to quite realize that history will go on even after I die, but we think less about what the future in the absence of humanity altogether, and that somehow we will become extinct. We will evolve into something else that is almost unrecognizable to us. After all, this took place in only 7 million years since we had a common ancestor with the chimpanzees, and given a 4.6 billion year history on Earth, that's not even a very long time. So within a few million years, it's virtually certain that we've evolved into something else, or like 99.9% of other species on Earth that have existed, that we've gone extinct for whatever reason. We are not here forever. And so this coming of age is associated with mortality and thinking about the future without humanity. So these are some of the issues that come up, it seems to me, in SETI challenging big history. I would say that it extends or builds on big history as well, as leading us to think about a new stage in emergent complexity. In addition to these stages that we've talked about before, that after the multinational or human stage, or the international stage, we have relationships between kinship groups, between cities and villages, between nations and empires. Now we can imagine relationships between planets, interplanetary, galactic relations. Now this can seem a little woo-woo at some point. It certainly has attracted a lot of attention ever since H.G. Wells and War of the Worlds and the popularity of Star Trek and Star Wars. I mean, this idea of interplanetary or intergalactic relations has attracted a lot of people's attention, most of it in the realm of science fiction or so on. But SETI is asking us to take this very seriously and to think about what would it mean if we do discover life on other planets, much less if we discover intelligent life on other planets. How does that change our own self-definition? What could that mean for practical relationships? What are the motivations that we have for this? What are the expectations that we have for this? Whatever those expectations and motivations are, it certainly is a next level of complexity in relationship, something which we've never had to deal before. I mean, when you look back historically, it's a little bit similarly to the Europeans discovering not only new land but new peoples in the Western Hemisphere, something which they had not they had expected when they began the discoveries. Columbus never did think he reached a new world. It was only really after Columbus that Europeans finally determined that this was the Americas were a new continent, and the peoples who lived there were very surprising that they were existing there at all. It would be even a greater transition for us to come to some new set of self-realizations of who we are if we discovered new life on other planets. This would be an enormous transition, and this gets us to it reinforces the movement of thinking about how we can form new relationships with these new entities that we have self-consciously sought out. And so perhaps it's not a mistake that it's the SETI folks who invited the big historians in for a conference where we think about these things together. They've been doing this now for many decades. They have been explicitly seeking new relationships with new entities to form new types of even more complex relationships. This interrelationship between SETI and Big History comes out of the SETI tradition of doing all of that, which in many respects is the best of the human experience, and in which we seek new relationships with new partners. And we understand that they have their own origins and their own histories and their own development, and that together we seek new definitions, even more complex sets of relationships that can serve us all, we hope, relatively well. And that will be the purpose of our symposium here as we discuss these topics over the next couple of days.